Hello friends, welcome to Physics Platter. In Physics Platter, today we are going to discuss about the image formation by a spherical mirror. Okay, so in this video we are going to talk about the image formation by both concave and convex mirrors. But before that, we will talk about the rules by which we can do the drawings of the image formation by, or the ray diagram of the image formation by the spherical mirrors. So this video is going to be a little bit longer than my other videos because we are going to talk about the rules first, and then we will talk about, for a concave mirror, 6 cases. That means we will keep the object at 6 different places and then find out where the image forms, and the 6 places are at infinity, then beyond C, at C, beyond C and F, between C and F, at F, and between F and P. Okay, and then for convex mirror, we will discuss about 2 cases where the object is at infinity and the object is between pole and the infinity. Okay, so these are the total. We will talk about the 8 cases and then the rules to draw the image, the ray diagrams. Alright, so let's go. So let's first talk about the rules of a concave mirror. What are the rules? And before that, I must tell you that in this video we will talk only about the extended objects, the image formation by the extended objects, and this is how you draw the object, where the arrow represents the head and then the leg or the tail of the object is at the principal axis. Okay, if I name it A, B, B is the head, A is the tail of the object. Okay, as we know, from the head or from any point of the object, this is we will consider this as a source of light. Light is going in all the directions, right? Light is, let's consider first the head. Light is going in all the directions. Infinite number of rays are coming out of the head. But which rays are useful for drawing the images for us? So basically we will talk about the 4 rays that we can take for the image formation, because we can easily implement our rules to the 4 rays. So what are the rules and what are the rays? First thing is that a paraxial beam or paraxial ray always goes through the focus of the concave mirror. We know that, right? So we can draw a paraxial ray which after reflection will go through the focus. That's one ray. Okay, secondly, if any ray goes through the focus of the mirror, that after reflection will become a paraxial ray, right? Let me draw like this. Excuse me. That is, yes. Okay. So any ray that goes through the focus of the mirror after reflection will become a paraxial beam or paraxial ray. Okay. Thirdly, if a ray goes through the center of curvature of the mirror, then let's draw this one like this. Then after reflection, it follows the same way back, because as we know, the line which goes to the center of the curvature falls normally on the spherical mirror. Okay, so 1, 2, 3 rays, and then finally another ray we can draw from B to P. From B to P, and then this is the angle of incidence. We can draw angle of reflection exactly as the same, and then draw a reflected beam just like that. Okay, so how many rays are there? 4 rays we can draw. Minimum 2 rays are required to draw an image, right, of an object. 2 rays, and one of which is paraxial, and another is through C. Another is through C. So these are the 2 rays I will take to draw my image by the concave mirror. or convex mirror. Alright, so these are the rules. Then let's go to the image formation by the concave mirror. So the first case is when the object is placed at the infinity. So let's draw a concave mirror. This is my concave mirror. This is the principal axis. The pole somewhere here, center C, and then focus F. Okay, so from the infinity, when the ray comes, it becomes a parallel beam, right? For example, the ray from the sun is always considered to be parallel. So we will consider two parallel rays in this case, just like that. And after reflection, this will go like this. That means the image will be formed. This is the focus F at the focal plane. Not exactly, not on the focal point, but in the plane which is perpendicular to the principal axis and at the focus. Okay, so this is the first case. What kind of image is that? So when if object is at infinity, the image is, first of all, what kind of image is that? Real image, because it is formed by the converging beam. When the beam is converging to a point and the image is formed. Secondly, it is diminished. Why diminished? Because the size of the image is very small compared to the object. And then thirdly, what? Thirdly is it is inverted. It is inverted, means it's upside down. Alright, so these are the three properties of the image formed by the object which is at infinity. Okay, let's move on to the second case, number B, which is where object is beyond C. Beyond C. So here we draw the concave mirror. This is the principal axis. So this is my pole, some center of curvature is somewhere here, and then the focus is somewhere here. Now I put an extended object beyond C and I name it as A, B. Okay, where B is the head, A is the tail. So as I told you, I will take two rays. One is paraxial ray, which is like this, which is parallel to the principal axis, and after reflection a paraxial ray will go through the focus, as you know. Okay, another one I'll take to the center. I can extend this a little bit. So this one is my center. Now, as you know, when the ray goes through the center, after reflection it comes back in the same path. So this is the point where the two rays meet in reality. So here my A prime is here and B prime is the head. So A prime, B prime is the image. So image is formed in between the, here I should write that image is formed at focal plane. This is another property, of course. Okay, here image is formed between F and C, means focal point and the center of curvature. So what are the properties of this image? First of all, it's between F and C. Secondly, it is diminished again because it is smaller. Thirdly, it is again inverted or upside down, right? It is inverted or upside down. And then fourthly, it is real. It is also real. Alright. Okay, let's move on to the third case. Third case, I bring the object. I see here I started with the object at infinity and I am coming slowly closer to the mirror. Now we will go on the C. And we will see what happens. On C. C here, F here, and I keep my object on the C. Alright, and I name it as, of course, A, B. Again I will draw a parallel paraxial beam from the head, and that will go through the focus. Alright, see, this time I cannot draw any ray through the center of curvature. So this time I will take another ray which goes through the focus, just like that. And then when it goes through the focus, after reflection it will become a paraxial beam. That means this has become my A prime, B prime, the image. See here, the image is of the same size as the object. Okay, so what are the properties here? First of all, the image is formed at C. Image is again real because it is due to the two converging rays. They meet at a point and forms the image, right? Thirdly, it is again inverted. Okay, and then fourth is it is of the same size. It is of the same size. Alright, so third case is discussed. Now let's move on to the fourth case, where I go with the object even closer to the mirror, and I keep the object between F and C. Keep the object between F and C. Alright. So let's draw again a concave mirror. P, C, F. This time I keep the object between C and F, right? So somewhere here. Let's say this is AB. Again I will draw a paraxial beam which will, after reflection, go through the focus, and then another beam which, see here also it is a little bit difficult to draw from the a ray which goes to the center of curvature. So again I will draw a ray which is through the focus, and then after reflection it will become a paraxial beam. So this is my A prime, B prime. The image is formed here which is beyond C. So what are the properties of the image? First of all, it is formed beyond C. Secondly, it is real again. Third, it is magnified this time. It is magnified. And then fourth, it's what? Fourth is it is inverted. It is inverted again. Beyond C, real, magnified and inverted. Okay, the fifth case is when the object is placed at the focal point. Okay, so let's draw a concave mirror again, and then principal axis, the polished surface, and then the pole center is somewhere here. Let's say this is C, and in between this is F. and this time the object is kept at the focal point, right, and I name it as A, B. Alright, so in this case I will draw, first of all we will take the paraxial ray, which is this, and after reflection what will happen, the paraxial ray, it will go through the focus, right, and then I will draw another ray which goes through the center of the curvature, just like that. So it goes like this, and after reflection it will come back to the same path. This time we see the ray becomes parallel to each other, right, that means the image will be formed at infinity. And what kind of image will be there? It will be a real image. So what are the properties here? First of all, the image is formed at infinity. At infinity. Then second, it is a real image. Third, it is a real image inverted, of course, again because it's below the principal axis, inverted. And number 4 is that what is that? Inverted, real, infinity, and then it is highly magnified. Highly magnified. Okay, so these are the 4 properties of the image formed by the object when the object is placed at the focal point of the concave mirror. Okay, let's move on to the 6th case, where the object is placed between P and F. Again we will draw a concave mirror, P, then center of curvature C, and then focal point somewhere here is F. This time we keep the object between P and F, AB. Okay, again we will draw a paraxial beam which goes through the focus after reflection, and then another beam which goes to the center of the curvature. Okay, this time see, after the reflection the beam becomes diverging, right? That means they will never meet in reality, which means the image will be formed somewhere in the back side, somewhere here. So this one, A prime, B prime. This time the image is not formed by the convergent beam, but it is formed by the divergence of the beam. Okay, when we extend the divergent beam, we see the image. So what are the properties of the image? First of all, the image is formed beyond the mirror. It is beyond the mirror, behind the mirror also you can say. I would rather say behind the mirror. Behind the mirror. Secondly, it is virtual. Third is what? It is erect, because it's on the same side of the principal axis as the object. And then fourthly, it is magnified again. It is magnified again. Okay, so these are the 6 cases of the object, 6 positions of the object where we have discussed the formation of the image by a concave mirror. Now we will move on to the convex mirror. Convex mirror. So what is a convex mirror? A convex mirror is when the outer surface of the curvature is reflecting. Okay, C somewhere here in between, this is P, in between P and C there will be the focus. Alright, this time the object will be in the opposite side of the center of curvature on the focus, right? So somewhere here, let's say as I told you, we will discuss about two cases. First case is what? Extended object at infinity, and the object at between the pole and the infinity. So when you talk about the infinity, the beam comes parallelly. First case, let's say this is infinite, when the object is kept at infinity. What happens after reflection? After reflection from a convex mirror, the paraxial beam diverges in such a way that they look like they are diverging from the focus. That means the image will be formed at the focus, and it is of course virtual, diminished, and then it is beyond the mirror. Alright, let's discuss the last case, which is number B. In case of the convex mirror, we keep the mirror, the object between P and infinity, pole and the infinity. Okay, so let's draw the convex mirror. C is somewhere here, P is somewhere here, this is P is somewhere here, this is it. Okay, so between P and anywhere between here, so this is my object AB. So again from the head I will take two beams, two rays. One is paraxial, that after reflection will look like coming from the focus, and then another one from C, a ray which was going towards C, and then of course it will come back to the same path, through the same path, and then the extended line will meet here. That means the image will be formed here, which is A prime B prime. So image is formed between the P and the F. So what are the properties of this image? This image is first of all at between, it is formed between P and F. Second is what? It is virtual, because again the image is not produced due to the convergence of the beam, but we had to extend the beam to find the image, right? Third is it is erect, and then fourth, erect. Why? Because it is at the same in the same side as the object, and then fourth is it is diminished, smaller than the object. Okay, so these are the four properties. Here in case of the convex mirror, we had considered only two cases, two cases where we keep the object at infinity and beyond P, between P and infinity. Why? Because in this case we cannot keep the object between C and P, because the C and F are in the opposite side, right, of the reflecting surface. Okay, so these are the 8 cases that is involved regarding the involved with the image formation of a spherical mirror. I hope you understood the image formation by the spherical mirrors. If you find this video, sometimes I was a little bit fast, sometimes I was a little bit slow, so just you can pause the video whenever you had difficulty in understanding and listen it again and again. I hope this video was useful to you. Take care, and then like my videos, share, subscribe my channel, And if you have any question, queries or suggestions, please write in the comment section. Okay, all right, bye.